We just talked about slope and y-intercept. Slope is the constant between all pairs of points on a given line. Determine the equation of the line that passes through the points -4, 14 and the point 1, -11. Well, if I were to draw a line that would create these points, I would see that we have a positive slope here since we're going up and to the right. If I were to draw a triangle so that we can identify what that slope is, I see that I rise 3 units and I run 5 units to get from one point to the other. We're talking about the change in y over the change in x. The y-intercept must be somewhere in between here, which would have to be at 0, -11 and 3/5. So to get there, I would start at -11 and I would go back 1 unit to get from the x value of 1 to 0, and I would have to fall 3/5 of a unit to get to 0. Therefore, my y-intercept is 0 and -11 and 3/5. The equation of this line is y equals 3/5 x minus 11 and 3/5. We can use the fact that the slope is constant between any 2 points on a given line to find an equation of that line in the form of y equals mx plus b, using a little bit of logic and where things are placed on the graph. Math is another language with its own symbols and grammar. To communicate well in math, we must learn to translate words and ideas from the language we know into numbers, expressions, and equations. We're going to translate the following. 3 times the sum of a number n and 6 is equal to 8 more than 4 times that number. Let's start with the left-hand side. We need to take 3 times the sum of some number and 6. So I'm taking the sum of n and 6 and multiplying it by 3. Is equal to, gives us the equal sign. On the right-hand side, 8 more than 4 times that number. More than means to add, so 8 plus 4 times whatever that number is. It's not asking us to solve, it's just asking us to translate. 3/5 of some number n added to 9 is equal to 4 times the sum of that number and 12. So we'll start again on the left-hand side of the is equal to portion. 3/5 of some number n, we're not quite sure what it is, added to 9. So 3/5 n plus 9 is equal to 4 times the sum of that number and 12. So this goes back to the first problem. We want 4 times a certain sum, and that sum is a number and 12. So I want to take 4 times n and 12. The difference of some number n and 15 is equal to the quantity of n added to 7 divided by 2. So the difference of some number n and 15, the difference meaning subtraction, so n minus 15 is equal to the quantity of n added to 7 divided by 2. So the quantity n plus 7, all of it divided by 2. The quotient of some number n and 4 is equal to 3 times the sum of n and 12. The quotient means to divide, so we want to take the division of n and 4 is equal to 3 times the sum of n and 12. So this is like the first two, where we have taking the sum of n plus 12 and multiplying it by 3. Word problems that we translate into equations will have one, none, or infinitely many solutions. Can we write an equation from a solution? What things would you need to consider if you're going to develop your own equations that had one, none, or infinitely many solutions? We know that equations with infinitely many solutions are identical on both sides of the equation, such as 5x plus 3 equals 5x plus 3, or 9 equals 9. We also know that equations with no solution result in a false statement, such as 3 equals 9, or x plus 4 equals x minus 6. Finally, we know that equations with one solution have a variable on one side and a constant on the other, such as x equals negative 7. Can we write an equation from a solution? Let's start with the following three solutions and write equations that would result in each of them. X equals 9, 3x plus 5 equals 3x plus 5, and 7 equals negative 3. Let's start with x equals 9. So this is a one solution. Let's say I add 5 to both sides. That would give me x plus 5 equals 14. And since I did the same to both sides, they are still equivalent. Now let's multiply both sides by 2. 2 times the quantity of x plus 5 is equal to 2 times 14. That would give us 2x plus 10 is equal to 28. We can stop here, or we could keep going, and we have created one out of many different ways for the statement for x equals 9. Let's move to 3x plus 5 equals 3x plus 5. And let's say I subtract 1 from both sides. That would give me 3x plus 4 equals 3x plus 4. Now let's multiply each side by 5. Simplifying would still give me 15x plus 20 equals 15x plus 20. No matter what we do, we will always get the same on both sides of the equation. The same can be said for the false statement. No matter what we do to both sides, when simplified, the answer will still be false. We can use the same operations on expressions as we use with numbers. So on the left and on the right, you see I have the exact same equation. Let's solve it two different ways. So let's first start by taking 3x and adding it to both sides, so that I still have 3 times the quantity of 4x plus 2 equal to 12x plus 15. Then let's distribute our 3, giving me 12x plus 6 equals 12x plus 15. When I subtract the 12x from both sides, I see that 6 is equal to 15 is not correct, so this has no solution. Let's do the same thing, only solving it differently on the right-hand side. On the right-hand side, I'll first start by dividing everything by 3. So then the 3 in front of the 4x plus 2 disappears. Negative 3 divided by 3 gives me negative 1x equal to 3x plus 5. Then what I'll do is combine my x's on the left-hand side. So 4x minus 1x is 3x. When I subtract 3x from each side, we get 2 equals 5, which is not a true statement, so this has no solution. So although we did it in two different ways, we still end up with the same answer. You may even notice yet another way that we could solve and obtain a no solution. So there are many different ways that we can solve equations. No one is right over the other, just as long as we do the operations appropriately. Use the following equation to write a word problem. Make sure to use the proper mathematical vocabulary and state whether your problem has one, none, or infinitely many solutions. I have 3x plus 5 equals 2x plus 9. So what I first did was subtract 2x from both sides, and I get x plus 5 equals 9. So x equals 9. So now that I have like a context of what the problem is in our ending solution, knowing that we have one solution, we can come up with a word problem to match. Let's write a story problem about riding in a taxi. We could say that one taxi company charges $3 per mile with an additional $5 flat rate. Then another company charges $2 per mile with a $9 flat rate. We could then ask the question, after how many miles would the cost be the same? So then x would represent the value of the miles that we are traveling, and the equal sign represents the cost being the same. So we could find out, since we know that there is one solution, that there would be 9 miles traveled in order for both companies to be the same. A solution to a system of equations is an ordered pair that makes both equations true. Ashley is at the fair with 16 tokens. Games cost 1 token and rides cost 2 tokens. She wants to play twice as many games as rides. How many rides can she go on? So there's a couple different conditions. The first condition is that it's 16 tokens to use at the fair, 1 for a game and 2 tokens per ride. So I'm going to split my 16 tokens into 2 places, 1 token per game and 2 tokens per ride, so that I create an equation of 1G representing game plus 2R for rides equals 16. The second condition is she wants to play twice as many games as rides. So the number of games is twice as many as the number of rides. So games equals 2 times R. So let's see if we can break it down into some tables here to see if we can't find some solutions. So if she plays 10 games, she would then have enough for 3 rides left over. If she played 4 games, she could have 6 rides. And if she did 6 games, she could ride on 5 rides. Let's look at the number of games then. If we choose 2 rides, that would mean she would need 4 games. 3 rides would be 6 games, and 4 rides would be 8. Let's grab one of these and use it as our test point to see if it can satisfy both conditions. So let's try 6 games and 3 rides. So 2 times 3 gives us 6, so it satisfies the number of games that she wants to play. Does it satisfy the number of tokens? So 1 times 6 plus 2 times 3 does not equal 16, since 6 plus 6 is not 16. So let's try a different test point. Let's try 8 games and 4 rides. So 2 times 4 is 8, so it satisfies the number of games. Does it satisfy the tokens that she has? So 1 game, so 1 times 8 plus 2 times 4 is 8 plus 8, so 16. So she can play 8 games and ride 4 rides, and it satisfies both conditions. How can you take 4 inches and make 2 segments where one segment is 1 inch longer? So our first condition is that we have 2 numbers that have a sum of 4. So x plus y equals 4. We don't know what those 2 numbers are. The second condition is that they have to have a difference. So when I subtract them, we get 1. Let's try our test point 3 and 1. So when I plug 3 and 1 as my test points, 3 plus 1 is 4, but 3 minus 1, when I take the difference, is equal to 2. So those won't work. Let's try 2 and 2, because I know 2 plus 2 is 4, but 2 minus 2 is not 0. So maybe let's try a decimal. So 2.5 plus 1.5 is 4, and when I subtract 2.5 minus 1.5, I get 1. So 2.5 and 1.5 are my solutions. So if an ordered pair substituted in both equations makes both equations true, it is a solution.